It's a real pleasure for us to have with us today Denham Parker. Welcome. Denham is a postdoctoral fellow in the Department of Biological Sciences, where he's researching in fishery science. Thank you, Denham, for being here.
Thank you very much for having me.
We've been talking about extinctions, and a lot of what we've spoken about has to do with extinctions in the terrestrial realm. But I'm wondering, what is the effect of high atmospheric carbon dioxide in the atmosphere? How does it actually affect the oceans?
Thank you very much. It's a pleasure to be here. There's two main effects with the high CO2 in the atmosphere, the effects on the oceans. The first is obviously what we call ocean acidification, and that's a direct effect of CO2 or excess CO2 in the ocean. And what we're finding is that the oceans are essentially large carbon sinks for CO2. So the oceans absorb about 1/3 of the carbon dioxide that humans make.
Really?
And that really leads to an astronomical number of about 20 million tons of CO2 per day. So that's huge. So when it absorbs all the CO2, there's a change in the chemistry of the ocean, and mainly it becomes more acidic. It turns into carbonic acid, and that affects a particular group of species called the calcifiers. And the calcifiers are a species that really need to lay down a hard exoskeleton. So we're talking about things like clams and mussels and lobsters, etc. And they need carbonate ions to be able to lay these things down. And with this change in chemistry, those ions are no longer available. And that means that they need more energy to lay down these exoskeletons. And sometimes the exoskeletons are thinner and more fragile. And the effects on those particular groups of species is large. The second effect is something called coral bleaching. And this is a direct effect of an increase in the temperature of the ocean. So we see the greenhouse gases, or the increase of CO2 increases the temperature of the atmosphere, and so does it increase the temperature of the oceans. And coral bleaching, essentially corals are made up of two organisms. You have the coral polyp and you have the zooanthelle, which is a single cell algae as such. And that's what makes up the color of the coral, gives them those beautiful colors. And when you have prolonged increased temperatures, that symbiotic relationship that those two organisms have breaks down. And the coral polyp essentially expels the zooanthelle, and therefore we get the coral bleaching. The corals tend to lose their colors. So those are the direct effects. Obviously, we know what happens on the corals and we know what happens to the calcifiers. What we really struggle to understand is the broad scale effect of this. How does this affect the ecology of the ocean on a global scale? And that really is where we struggle to predict what the effects are going to be.
So in terms of extinctions of organisms themselves, I mean, how do we see the extinctions in the sixth extinction in the oceans? I mean, is it the same as it is in terrestrial environments? So for example, if you compare freshwater environments versus marine environments.
Okay. Freshwater environments and marine environments in terms of extinction rates differ significantly. What we find in the freshwater environment is that there's a very high extinction rate. In fact, it's the highest that we're seeing in all the environments at the moment. Particularly freshwater fish, we find that about 36% of all freshwater fish at the moment are threatened or vulnerable.
Is that because of pollution, or what is causing it? What is the main driver for these extinctions?
It's mainly habitat modification, and unfortunately the freshwater environment suffers from something called island biogeography or insular biogeography, where the ecology of a freshwater system is so different than its surrounding ecology, because it's surrounded by a terrestrial environment, that these organisms are essentially stuck on that island of fresh water. So if there's any disturbance in that fresh water, they either have to be able to take that disturbance or they actually end up dying because they can't move away from it. And that really increases the extinction rates in the freshwater. In contrast, what we see in the marine environment is that it's a very fluid and expansive environment. So there's no physical boundaries as such. So if you see a disturbance in an area, the species can literally move away from that. And that's a big difference. But one thing when you talk about marine extinctions that you really have to understand is that the marine environment is largely undiscovered when compared to the terrestrial environment. And we've estimated that there's roughly about 1.9 million species that we've discovered in the marine environment. But we've also estimated that there is possibly 9 million species out there. So the question is, you don't know what you've lost if you never know what you had in the first place. So it's largely an underestimate. We probably have around 20 extinctions in the marine environment. A lot of them are the mammals or seabirds that depend on the land to some extent and air breathing, and only 2 marine fish that are documented to have gone extinct.
But we know that overfishing, for example, is putting a lot of stress on many populations of fish. I mean, are there particular fish that are being threatened or on the endangered list that we need to be more careful about?
Yes, overfishing obviously plays a massive role. We're altering the habitat, or we're altering the ecology of the ocean in a huge way. So it's very devastating. But I must stress that overfishing hasn't led to an increase in extinction rate of fish. And there's a number of reasons for this. The first is biological and has to do with the fecundity of fish, which is the potential of a fish to reproduce. Any one average fish in the marine environment could possibly produce tens of thousands of eggs at a single...
At a time, yeah.
Yes. So that really creates resilience against going extinct, because a small amount of the population can really sustain the entire population if they're reproductively active. The second is something to do with a more economic scale. It's called the Gordon-Schaefer model, which basically describes the relationship between the cost-benefit analysis of a fishery. And what that basically says is that it's too expensive to fish a species to the last fishery. So the fishery collapses or the fishery closes down before you're able to actually fish it to the last fish. So that means that the fish are able, or the fishery stops before the fish goes extinct.
But I'm sure there are many people out there wondering, if we can actually think about commercial farming of fishes rather than actually catching fish wild. I mean, to prevent over-harvesting or to try and eat wisely. I mean, is there ways in which people can do these things?
Yes, definitely. I think what we need to understand is that the consumers play a massive role in this. The consumers really hold the power to determine what the future of fishing and overfishing looks like in the world. If you decide not to support an unsustainable practice, that practice should eventually not be viable.
Yes.
But in terms of what we need to focus on at the moment, I think it's largely awareness. Awareness on two fronts. Awareness as a seafood consumer, and awareness as an ocean user, someone like a fisherman. In terms of a seafood consumer, you really need to know what you're eating, how sustainably that's harvested, and where it comes from. And there are a number of apps and such out there that help you do this. Globally, there is the MSC, which is the Marine Stewardship Council, which goes to all these fisheries and basically audits them in terms of their sustainability. And then they get certified if they pass the audit.
So if you buy fish, it'll have a certain stamp on it?
Yes, it will have an MSC certified stamp on it. So those are the type of products you need to be looking for and possibly making your choices for. Locally in South Africa, we have something called SASSI, which is the South African Seafood Sustainability Initiative. And that categorizes every single species into one of 3 categories: red, orange and green. Green obviously being your most sustainable, so that's really what you want to be going for. Orange you should possibly think twice about buying, and then red is completely no take. So you want to be avoiding red listed species. And that's a very simple but very effective way of giving consumers an idea of what choices they should be making and driving a more sustainable fishery in the future. And then in terms of an ocean user, so a fisherman for example, there are a number of regulations out there that you need to adhere to, and these include bag limits. How many fish are you allowed to catch in a single day? What is the minimum size for that particular species? And when am I allowed to catch these fish? And these are all there to promote sustainability of the recreational fishery. So you need to be aware of those regulations and you need to adhere to them. And I think if we could get those 2 areas of awareness right, we really could promote sustainable fishing in the future.
Wonderful. Denham, thank you very much for being with us here. It's been such a pleasure talking to you. And I think all the people that have registered for this course have learned so much about extinctions, both in the freshwater as well as in marine environments. And I think our concluding remarks about, what people themselves can do to make a difference in terms of good habits for sustainable fisheries is just wonderful. So thank you so much.
It's a pleasure.